If everything works out as expected, it will be a revolutionary era for astronomy. The James Webb Space Telescope, JWST, the biggest, costliest, and complex space telescope of all time, is presently in space, making a beeline for its final stop. The launch of the $10 billion James Webb Space Telescope on Christmas Day 2021, delayed by 10 years, was both energizing and startling for the many researchers, architects, directors, and care staff who carried the mission to this point. JWST's technical potential is enormous. In this video, we will discuss how the James Webb Telescope can find signs of life in the galaxy. All you need to know about the James Webb Telescope. Webb's origination is inspired by the Hubble Space Telescope, the 31-year-old observatory popular for catching staggering photographs of our universe's galaxies. However, Webb gets where its ancestor misses the mark, says Eric Smith, Webb's program researcher and boss researcher of NASA's Astrophysics Division. There's actually no telescope like Webb up to this point, he says. The new observatory, which is sent off from northern French Guiana close to the equator, is a joint cooperation between the space organizations of the United States, Europe, and Canada. At the point when you can see Webb go into space, it's the entire power of human inventiveness and a wide range of disciplines that push it there. It is special in light of two capacities. In the first place, it's huge, with a 21.3-foot primary mirror that will make Webb the farthest-seeing telescope mankind has assembled. Also, Webb sees the universe in the infrared, the zone on the electromagnetic range with somewhat longer frequencies than apparent light. A few specs. It has a mission lifetime of 5 years with a 10-year goal and will hover in the L2 orbit at the second Sun-Earth Lagrange point, 1,500,000 kilometers from Earth. The sunshield dimensions are approximately 22 meters by 12 meters, with a primary mirror of 6.5 meter diameter aperture. It employs technologies like sunshield membrane material, near-infrared and mid-infrared detectors, lightweight cryogenic mirrors, micro-shutter arrays, and so much more. How the Webb works. Webb is multiple times more sensitive than Hubble. While Hubble worked basically at optical and bright frequencies, Webb will actually want to see the universe in the infrared range, looking through billows of gas and residue where stars are being conceived. The new telescope's main mirror has a lot greater light-gathering region that permits it to notice objects at more noteworthy distances. And now, this is how the James Webb Telescope can unravel the answers to the trickiest questions within the space domain. 1. Find chemical signs of life. Assuming life exists outside of Earth, it will deliver particular substance marks or indications, for example, by breathing carbon dioxide and photosynthesizing out oxygen, that can change a planet. Examining the synthetic substances in a planet's climate won't just permit researchers to search forever, yet in addition empower them to evaluate a planet's tenability. Webb can distinguish infrared frequencies for fingerprinting synthetic compounds, for example, water and methane present in the air of exoplanets, which are planets past our solar system. Webb contains two instruments that will permit researchers to disentangle the frequencies of infrared signs from planetary groups past our own to unweave the colors of the infrared rainbow, as it were. When an exoplanet photobombs a star that our telescopes are looking at, the starlight will encounter a plunge in specific energies compared to the synthetic substances in the exoplanet's climate. In the event that Webb is taking a gander at the perfect star at the ideal time, it can artificially break down the air of the star's planet by dissecting the blip in the starlight. In any case, how humankind might interpret these exoplanets has scarcely stretched out past the way that they are there. It's challenging for current innovation, like Hubble or on-Earth infrared telescopes, to complete infrared spectroscopy on new exoplanets of interest. Hubble works with a much smaller band of infrared energies contrasted with Webb. Ground observatories are covered in Earth's environment, which itself is a safeguard and scatterer of infrared light. The Earth additionally emanates infrared radiations that would overpower the weak signs coming from the profound universe. In space, where Webb will be, Earth's air and warm transmitting surfaces are far removed for an unhindered perspective on the night sky. 2. It might track down alien life. The Space Observatory will likewise explore whether planets outside our own planetary group might be inhabited by alien life. Cameras on the telescope will take pictures of different planets to search for the presence of water and different traces of life in the climate. Professor Martin Barstow, a researcher who fostered the device, said it could uncover the presence of extra Earthbound life structures in space. We will find out about the starting points of the universe and how life occurred, and possibly, in spite of the fact that we can't ensure, about other life in our system too, he said. He explained the launch as the start of another time in space science. The telescope is so critical that it will totally alter the manner in which we view the universe and the manner in which we view our place in it, he said. One of the enormous motivations behind these telescopes is its use as a time machine, since distance here is look-back time, says Daniel Eisenstein, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics. Eisenstein will utilize Webb's cameras to time travel back to when the earliest cosmic systems were forming just after the Big Bang. At the point when we take a gander at a far-off universe light years away, we aren't seeing it in its latest state. Its distance in light years means the quantity of years it takes for its light to show up to Earth. For instance, the nearest world to our own is the Canis Major dwarf galaxy, which is 25,000 light years away. So its light requires 25,000 years to arrive at Earth. That implies when we see Canis Major dwarf, we're seeing it as it was 25,000 years ago, a long time back. The further into space researchers can look, the further back in time they can notice a system. Webb, being the farthest-seeing telescope yet, can uncover the most youthful-looking worlds mankind can notice. To comprehend the arrangement of worlds, researchers like Eisenstein will take an in-depth look at a few universes at various life stages and sort out their formative schedules. Webb's infrared abilities are additionally significant for noticing these universes. When the light arrives at our telescopes, its unique frequency will have moved from the apparent or bright to the infrared. Fortunately, getting infrared signs is definitely in Webb's wheelhouse. It's the first time we've had a huge cold telescope in space that can notice these infrared frequencies, said Eisenstein. The Hubble Space Telescope has figured out how to catch the most brief frequency infrared beams extended from the bluest of light of distant universes. The retired Spitzer infrared telescope was a lot more modest than Webb and couldn't be considered to be far into space. Webb will nail it as far as how profound into space and how far back in time it can get away from cosmic systems in the process of growing up. 3. Additionally, it can also study black holes. Nothing can get away from a black hole, not even light, so actually, black holes are invisible. Fortunately, twirling around them is a lot of stuff we can see, such as stars, residue, and whole galaxies. To concentrate on black holes, researchers investigate this display, like concentrating on a shadow to find out about its shadow-projecting article. Previously, researchers have utilized X-beam telescopes to concentrate on unambiguous sorts of physical black holes. These telescopes take a look at peculiarities that are very hot and sufficiently high to deliver X-beams, for example, the vicious destruction of stars meandering excessively near a dark hole. Webb's infrared instruments will permit researchers to see various activities in a black hole's corner, especially the cooler gases and stars moving around their undetectable neighbor. The James Webb Telescope is about 1.5 million kilometers from Earth. We wonder what astounding science waits for us with JWST. This is the end of this video. Thank you.